normally distributed mean of 760 standard deviation. Okay, 760. Between 705. So between 705 and 815 is 78.87. Okay. Write down the probability they weigh more than 760. Oh, that's a 760. So if it's more than 760, it must be 50% because that's the mean, or 0.5. Find the probability of weigh less than 815. Okay, so between 705. So we need to. What's this value here? It's 45. 45. No, 55. Oh, so this is symmetrical. Okay, so these are both equal. So 78.87 divided by 2. 39.43. Sorry, I need to explain this. 39. What was it? 435. Okay, so we can see that if this is 705 to 760, that's 55 units, and then there's 55 units between 860 and 815, which means that these are equal distance away from the mean, which means that this probability here is like each of the halves would be half of this. Okay, so the total amount is one value, and then each of these are exactly the same, but that's only because that this gap between the 815 and the 760 and the 705 and 760 is the same. Okay, so if, we know that the total probability of greater than 760 is 0.5, and this portion here is 0.3939435. Then we want to know, if we want the probability less than 815, it's going to be this amount plus 0.5. So it's going to be 0.5 plus 0.39435, which is 0. Oh, that's so not 0. 0.89435. You can leave it exact if you wish. Write down the standardized value for 815. Okay, so that means they want to know the z-score. So remember, we would use our distribution, and we'd use inverse normal. Now, we know that the probability for this is 0.89435, so we type in there 0.89435. And we keep the mean as 0 and the standard deviation as 1. Now that's going to tell us the equivalent z-score, because we use the same probability as for the 815. So that's 1.2536. Okay, hence or otherwise find the standard deviation. So, reminding ourselves of this formula here. So, we know that 1.25 is equal to 815 minus 760 over standard deviation. So standard deviation is 55 over 1.25. Which is 44. A fishing contest takes place in the lake. Small fish called tiddlers are thrown back into the lake. The maximum weight of the tiddler is 1.5 standard deviation below the mean. So 1.5 times 44. And 760. 66 is 694. If a fish is caught as ram, find the probability it's a tiddler. So we're gonna use our distribution, normal CDF. So our lower can be that. Our upper is going to be 694. Our mean is 760. Our standard deviation is 44. And that's 0.0. I can't bother to write it down. Okay, 25% are salmon, 10% are tiddlers. Given that a fish is caught ram, is find the probability it's a salmon. Okay. Oh. Okay, so conditional probability. I feel like we've had one of these, but maybe it's just because I've done lots of papers today. And so we're using conditional probability. So remember rearranging this. So we want the probability of it's a salmon and a tiddler over the probability that it is a tiddler. So the intersection would be 0.25 multiplied by 0.1 over the probability it's a tiddler is 0.06687 that we just worked out. Gives us 0.378. Oh, maybe I was too accurate. Or maybe I didn't find the right number. .668. 0.374. And that's the end of that paper.